All right, let us quickly solve this Olympiad math problem. Okay. Now, we are given this. First of all, for us to remove this square root, we have to square both sides. So if I square both sides, I'm going to have that this is 3 raised to power x minus 4 raised to power x all squared is equal to what? Square, take care of square root. So I'm left with what? 12 raised to power x minus 16 raised to power x. Okay. Now, this one is in 3 and 4. So let us try to reduce this to be 3 and 4. So this is something as saying 3 raised to power x minus 4 raised to power x, okay, all squared is equal to, now this one can be written as 3 times 4, okay, all raised to power what? X, minus this one can be written as 4 times 4 all raised to power x, okay. So now I'm having that this is 3 raised to power x minus 4 raised to power x is equal to, this is 3 raised to power x, 4 raised to power x minus 4 raised to power x, 4 raised to power x, okay. Now this is, sorry, we have all squared here, don't forget, okay. So I'm having that this is 3 raised to power x minus 4 raised to power x, okay, all squared is equal to, now they have something in common, they have 4 raised to power x in common. So I'm going to have 3 raised to power x minus 4 raised to power x, okay. So that this time this is giving me this one, and this time this is giving me this one, okay. Now if you look at this now, you see that this and this are now the same thing, so you can quickly say let that 3 raised to power x minus 4 raised to power x be equal to y, okay, because they are the same. So anywhere I see that, I can just put y. So I'm having that y squared, okay, is equal to, this is y, then squared is equal to 4 raised to power x in bracket of y, okay, in bracket of y. Now if I bring this to this side, I'm going to have y squared minus 4 raised to power x y is equal to 0, okay. Now let us factorize, they have something in common. I'm going to have y in bracket of y minus 4 raised to power x, so that this time this is giving me this, and this time this is giving me this, is equal to 0. Then don't forget that when the product of two things is equal to 0, then it means that one of them must be 0, okay. So we'll say that either y is equal to 0, or we say that y minus 4 raised to power x is equal to 0, okay. Now, so we have two cases here, so let us consider the first one, case 1. So the first case here say that y is equal to 0. Now what is my y? Don't forget what is your y. My y is what? 3 raised to power x minus 4 raised to power x is equal to 0, okay. So this one going here, I'm going to have that 3 raised to power x is equal to what? 4 raised to power x. I told you before, and you should know that what? Whenever you have an index problem like this, indices problem like this, where you have equality signs separating them, if the base are not the same thing to cancel out, then we must introduce logarithm. So we say that what? This is what? Log 3 raised to power x must be equal to what? Log 3 raised to power, 4 raised to power x, okay? 4 raised to power x. Now, according to the law of logarithm, the x can go to the back, okay? So, according to the law of logarithm, the x can go to the back. I'm going to be having that what? I'm going to be having x log 3, okay, is equal to what? X log 4. Now, what do we do? Let me bring this one to this side. I'm going to have that x log 3 minus x log 4 is equal to 0. So what do we have now? We're going to have that if you bring out x that they have in common, this is x in bracket of log 3 minus what? Log 4, okay, is equal to 0. So you're having that x is equal to what? 0 over log 3 minus log what? 4, so which is what? 0, okay. So I'm having that the first one is 0. So let's consider the second one. If we consider the second one, I'm going to have that okay. So let's consider the second one. Where is the second one? The second one say that this is the second one here. So let us consider that. Permit me to clean somewhere here, okay. So, and the second case, that is case 2. Case 2 said that what? That y minus 4 raised to power x is equal to 0. So, don't forget what is your y. My y is this, okay? So, my y is 3 raised to power x minus 4 raised to power x. That is my y. This is my y. Then you now attach the minus 4 raised to power x again is equal to 0. So, this is giving me that this and this is what? 3 raised to power x minus 2 times 4 raised to power x, okay, is equal to what? 0. So what do we have here? If we apply logarithm, or let us take this to the other side. If I take this to the other side, I'm going to have that okay, this is 3 raised to power x is equal to what? 2 dot 4 raised to power x, okay? So this is 3 raised to power x is equal to what? 2 raised to power 1 dot 2 raised to power 2x, okay? So this is 3 raised to power x is equal to what? 2 raised to power 1 plus 2x according to the law of indices. So we can now apply the logarithm again. So we say that log 3 raised to power x is equal to log 2 raised to power 1 plus 2x, okay? So now we'll do the same thing again. So if we do the same thing again, we're going to have that this x will go to the back. So I'm going to have that x log 3, okay, is equal to what? 1 plus 2x log 2, okay? This 1 plus 2x will go to the back. So if I'm going to clear the bracket, I'm going to have that this is now that log x log 3 is equal to, this time this will give me log 2 plus 2x log 2, okay? Collect like terms. This one can come here. So I'm going to have that this one coming here. I'm going to have that x log 3, okay, minus 2x log 2 is equal to what? Log 2. Okay, so they have x in common. If I have x in common, I'm going to have that what? Log 3, okay, minus 2 log 2 is equal to what? Log 2. So therefore, my x will now be equal to what? Log 2 divided by what? Log 3 minus 2 log 2, okay? So if you want to get it in decimal, you know that log 2 is 0.3010 all over. This one is 0.4771 minus 2 into 0.3101. So you can now do that and get the final result. All right? So thank you very much for watching. Please don't forget to like this video, share, and then subscribe. Bye bye.